down. It's not at all counterintuitive, but what happens if you drop something heavy, like this textbook, and something comparatively light, like a pencil? What's going to hit the ground first? Well, we are scientists. Let's find out. They hit the ground at the same time. So that's a bit odd, a little bit counterintuitive. So why is that? Well, one of Newton's laws of motion is that the force acting on an object equals the mass of that object times the acceleration that that object is experiencing. Now, we also know how to compute the force exerted by gravity between two objects. So, the force of gravity equals a constant g, which we don't really need to know, it's just a constant, the mass of object 1, the mass of object 2, divided by the distance between the two objects squared. So you've got object A, object B, and the distance between the two. Now, g is obviously a constant. And if we're talking about dropping things on Earth, like the pencil or the textbook, then the mass of the Earth, the second object in the situation, the mass of the Earth isn't going to change. It's constant. So that is constant. And the distance between the two objects, since we measure from the center of the Earth to the object, even though the object is falling, the comparative distance between the difference in the distance between the object before it falls and after it falls, compared to the center of the Earth, that distance is effectively 0. So r is also constant. So we've got g and m and r squared all as constants. And so if we're talking about on Earth, we call all of this just little g. So that means that the force of gravity on Earth equals g times the mass of the object being dropped. Incidentally, g just equals 9.8 meters per second squared. It always equals that on the surface of the Earth. So now, we have the force of an object. Force on an object equals the mass times the acceleration that it's experiencing. And if we're talking about gravity, that equals g times m. Now we can do just simple algebra. We've got the mass of the object on both sides, here and here. So no matter what that mass is, whether it's 100 pounds or 1 pound, we can just cross it out. And so we have the acceleration that an object experiences will always equal g. It will always equal the same thing. Now, I know what you might be thinking, but what happens if we drop this pencil and this Post-it note? What happens then? Those didn't hit the ground at the same time. Not at all. So, what happened there? Well, when you drop the Post-it note, there's a bunch of air that gets in the way. Lots of tiny little air particles. It's kind of like if you drop something in water. All the water gets in the way, so it sinks to the bottom of the pool slower. So if you were to put the piece of paper, the Post-it note, inside a vacuum chamber and take out all the air. Just take out all the air. So now there's no air at all that gets in the way, and you were to drop it and the pencil, they would hit the ground at the same time.
Gravity is working against me.